Good evening everyone. So today we are going to discuss fluid mechanics, right? So as you know that matters are broadly divided into three categories. So one is solid, as you know, solid, liquid and gases. Solid, liquid and gases. This categories, solid, liquid and gases, we see that the intermolecular force in different kinds of matters are different. The intermolecular forces in case of solids are much stronger. That is why the shape and size of the solids, they do not easily change, and the force, the intermolecular force, is comparatively lesser in liquids, and it is much more lesser in case of gases. That is why the shape of the liquid can be easily changed, right? So shape, it can be easily changed, as well as the shape of the gases can easily change. But the volume, the volume of a given mass of liquid cannot be easily changed. But the volume here, in case of gases, they can be, volume can be easily changed. They can be easily changed. But in case of a liquid, the volume of a liquid of given mass cannot be easily changed. So in this chapter, in fluid mechanics, we are basically discussing, we'll be basically discussing with, or sorry, basically discussing about liquids here, right? But the liquids plus gases, these two are called fluids. But in this chapter, in the present chapter, we shall be discussing about mainly about liquids, and the equations that we will be deriving, they can be applied to gases with some modifications, but mainly we shall be talking about liquids. But together, liquids and gases called fluids, that is, fluids are those which can flow, right? So we shall be largely discussing about liquids and about certain types of liquids. So the liquids about which we are going to discuss in this chapter, the liquids will be having certain properties, two properties basically. One is incompressible, and number two, non-viscous. Non-viscous. So see, this incompressibility, the property of being incompressible, it means that the density of the liquid is constant. The density of the liquid is independent of the pressure applied on it. Or that means no matter how strong a force be, how much pressure is applied on the liquid, is not affecting the volume of the liquid. So that is why incompressibility means the volume of the liquid is, the density of the liquid is constant. Density is constant, irrespective of the strength of the force applied to increase or decrease the density of the liquid, it will remain constant. That means incompressibility. And what about this non-viscous nature of liquids? The non-viscosity, the non-viscous liquid is such a liquid that the parts of the liquid, the layers of the liquid, the layers or parts of the liquid do not exert force, tangential force, do not exert any tangential force, on each other, right? So these two things should be remembered. That means it can be written. We'll be studying this viscosity in great detail in a later point of time. But this non-viscosity, in a very simpler manner, there will be no friction. In a very simpler manner, no friction between the adjacent layers of the liquid, right? So while discussing liquids or fluids in this chapter, this incompressibility, that is density is constant, should be considered, and non-viscous liquids will be considered here, right? Understood? So the thing that we are going to study in this chapter, that is the fluid mechanics, this fluid mechanics can be broadly divided into this part, or we shall be discussing this parts while studying fluid mechanics in this class. This fluid mechanics is actually divided into three parts. One is some mechanical, we shall be studying about some mechanical properties of fluid, such as surface tension, viscosity, etc. Number two, we are going to study about fluid statics. And number three, we are going to study about fluid dynamics, right? So what is fluid statics? Fluid statics is the fluid. See, the fluid should be contained by some container. It should be inside some container. So whenever the fluid inside a container is at rest with respect to the container, it will be studied under fluid statics, right? So here in fluid statics, we are going to discuss about the things when fluid will be at rest with respect to the container or vessel, right? And here while studying fluid dynamics, we shall be discussing those cases where the fluid will be in motion. Fluid will be in motion with respect to the container, right? So these three parts we shall be discussing in this class 11. Clear? So now, before discussing these things in detail, we shall be knowing a few terminologies about the fluid. What are those? That we shall be studying about the density of the fluid or liquid. Let us say about liquid. So the density of the liquid. So these are the few things that we shall be discussing. density of the liquid. Density of the liquid. Okay. So, what do you mean by the density of the liquid? What is density of the liquid? See, density of any substance, let us say, let us denote it by rho, right? Density of any substance is defined as the mass per unit volume. So that is rho is equal to mass upon volume, right? So mass is, let us say, mass is small m and this is capital V. So rho is equal to mass into capital V. As you know, the unit of rho is kg upon meter cube in SI system. So unit of density is mass. This is for SI units, let us say. SI unit of density is kg per meter cube. That should be the SI unit. What about the dimension? What about the dimension? This is capital M. So capital M upon L cube. So M L to the power minus 3. This should be the dimension. And now we are going to learn about relative density. In case of liquids, sometimes we shall come across another term which is called relative density, right? So what is relative density? Relative density, as the name suggests, relative means what? Relative means with respect to something. So this relative density is actually the ratio. The ratio of what? Ratio of the density of a substance to the density of water at 4 degrees Celsius, right? So relative density or RD is defined as the ratio of density of a substance upon density of water at 4 degrees Celsius. So this thing is very much important. This 4 degrees Celsius, this temperature is very much important. Why? This is very much important because this temperature, the density of water does not stay constant. See this temperature, this does not remain constant in all temperature. So this 4 degrees Celsius is a very important thing to remember, right? So RD, the relative density of any object, any substance, is actually the ratio. There is a pure ratio, right? So this RD is a pure ratio. This is a ratio, right? So this will be having no this will be having no unit, right? So there is no unit. It's a unitless quantity, no unit and unit dimension. Now the value of the density of water is a very standard value and you should remember it, right? The density of water, rho of W at 4 degrees Celsius, it should be remembered, right? It is in CGS, it is a very simple value, 1 gram per cc, 1 gram per centimeter cube. So at CGS, in CGS, it's a very important thing is to remember that this RD in CGS system, we are having density of a substance in the numerator and density of the water in the denominator, which is 1 gram per cc. So in CGS system, the denominator is becoming 1. So numerically, as you can see, numerically, the RD of a substance, RD of a substance is equal to its density. In which system? In CGS.